Hi friends, welcome back to C Level Physics. My name is Srinivas, known to be BS Rao. I requesting all the audience to please subscribe channel C Level Physics, which is very useful to all the students, right from the foundation level up to IIT JEE, including NEET aspirants. Okay. Moreover, please don't forget to like my videos, share my videos, and comment on my videos. Okay. Coming to topic, multiplication of vector by a real number. See, multiplication of vector by a real number, which is scalar. Means if you multiply given vector with a given real number scalar, what is the result? Let us see. See, a bar is given vector whose magnitude mod a bar equal to a. If it is multiplied by a real number, real positive number k, then what happens? It becomes a new vector. Why? Because after getting multiplication, what happens? Magnitude may changes. Magnitude changes. That is, it is a new vector here onwards. That is b bar equal to k times a bar. K times a bar. K is the real positive number. Thereby, modulus of b bar equal to mod of k a bar means k into a. The magnitude of new vector, that is b equal to k times previous magnitude. K times previous magnitude. When given vector is multiplied by a real positive number, then its magnitude increases k times. Direction will not be changed provided k is positive real number. See, both are along same direction, but length only increases. Why? Because here k is greater than 1, for example. Okay, thereby magnitude increases from a to k. Right? Now let us see second case, that is if k is a negative number. K is negative number. See, this is the given vector a bar whose magnitude mod a bar equal to a. Now it is multiplied by negative number minus k. Okay, definitely here onwards it becomes new vector, that is say b bar. B bar equal to minus k into a bar. Minus k times a bar. That is not b bar equal to mod of minus k a bar. That is b equal to mod minus k means k only. Why? Because modulus always gives positive values. K into mod of a bar means a. This time also magnitude of new vector increases k times, becomes k times previous magnitude. As far as direction is concerned, it is reversed. Why? Because k is negative number here. That is the reason why the direction is reversed. See, initially this is the direction for a bar. Now after getting multiplication by negative number, the direction is reversed. Okay. If at all k is 0, as an example, say this is the given vector a bar, mod a bar equal to a. If it is multiplied by 0, that is it becomes new vector b bar equal to k times a bar. That is k means here 0, 0 times a bar. That is 0 bar, null vector. This time they are getting null vector. What is the magnitude of null vector? Mod b bar equal to mod of k into a bar. That is k times a. That is k means 0, 0 into a. That is 0. What is the magnitude this times? 0. That is k times once again. Why? Because k is 0. Okay. So what is the inference here? If given vector is multiplied by a positive real number, then its direction will not be changed, but magnitude becomes k times the previous value. If it is multiplied by a negative real number, this time magnitude changes, similarly direction also changes. Means direction reverse, magnitude again k times. Okay. Now let us see multiplication of vector by another vector. Multiplication of vector by another vector. By another vector. Another vector. We have to multiply given vector with another vector. Okay. Here, multiplication of vector by another vector means here there are two types. First category, the result is scalar, means scalar product or dot product. In second category, if two vectors are multiplied such that we have resultant is again vector, then that kind of multiplication is said to be vector product or vector cross product. Cross product. Okay. Cross product. So if given vectors are multiplied such that the result is scalar, then that kind of multiplication is said as scalar or dot product. If at all resultant is again a new vector, that kind of multiplication is said to be vector or cross product. Now let us see scalar or dot product. Okay, scalar or dot product. Scalar or dot product of two vectors, right? Suppose here we have two vectors. Here we have two vectors. Say this is A bar, this is B bar. With theta is the angle between them, right? A bar and B bar are two vectors, with theta is the angle between them. Okay. Now, what is that unit vector along A bar? That is A cap. What is the unit vector along B bar? That is B cap. B cap. So A cap and B cap are the unit vectors along A bar and B bar respectively, right? Now, I am taking one normal from the tip of A bar onto B bar line. See, this is 90 degrees. See, this dotted line is nothing but normal drawn onto A bar, B bar. Okay, from the tip of A bar, right? Now, what is this measurement? Definitely, this measurement from here to there. What is that measurement? Usually, that is length of A bar along B bar. See, actually, this is the total length of A bar. Now, this is also length of A bar only, but along B bar. What is other name for this one? Projection or component or length or magnitude of A bar along B bar. So what is that? A cos theta. A cos theta. A cos theta. Right? Now this what? Projection. Projection or component of A bar along B bar, right? Similarly, if I draw one normal from the tip of B bar onto A bar, see, somewhere here, see, from this tip of B bar onto A bar, one normal is drawn. Usually this is what? This total length of B bar. Now this vector B bar finds this much of length along A bar. Along A bar. So this is what? B cos theta. B cos theta. B cos theta. Alright. So we can have component of B bar, B cos theta along A bar. Similarly, component of A bar, A cos theta along B bar. So A bar finds its component along B bar. Similarly, B bar finds its component along A bar. Right? So B cos theta is the component of B bar along A bar. A cos theta is the component of A bar along B bar. Okay. This is what? Component or projection of B bar along A bar. Okay. So B cos theta is the component or projection of B bar along A bar. Now, how can you measure the dot product of these two vectors A bar and B bar? Usually, the dot product of A bar and B bar can be written as A bar dot B bar. A bar dot B bar. And is measured as the product of magnitudes of both vectors, that is mod A bar and mod B bar. The product of magnitudes of both vectors multiplied both vectors and cosine of angle between them. Cosine of angle between them. What is the angle between them? Theta. Cosine means cos. So into cos theta. into cos theta. See once again, the dot product of A bar and B bar can be written as A bar dot B dot B bar. See this operation, dot operation, A bar dot B bar, pronounced to be dot here. A dot B, that is A bar dot B bar, can be measured as the product of magnitudes of A bar and B bar and cosine of angle between them. Angle between them. That is, mod A bar means A, mod B bar means B into cos theta. This also can be written as A cos theta into B. See, A cos theta, what term? A cos theta. What is A cos theta? The component of A bar along B bar. That is A cos theta. A cos theta into, we left with the B here. That is into B. Similarly, also can be written as A into B cos theta. A into B cos theta. A into B cos theta. See here, A means the total magnitude of A bar from here to there. Mod A bar means here. Into B cos theta means the component of B bar along A bar from here to there. Right? See, A bar dot B bar can also be measured as A cos theta into B. That is component of A bar along B bar multiplied by the total magnitude of B bar. Similarly, the total magnitude of A bar multiplied by the component of B bar along A bar. See, once again, A cos theta means what? The projection of A bar or component of A bar along B bar. So A cos theta into B. A cos theta into B. B means from here to there. A cos theta means from here to there. Means A cos theta multiplied by B. A cos theta multiplied by B. Similarly, A means from here to there, that is total magnitude, A into, from here to there, A into B cos theta means this is the B cos theta. So A into B cos theta. Otherwise, A cos theta into B. A cos theta into B. Otherwise, A into B cos theta. Both one and the same. So how can you define in another way means the dot product of two vectors can also be measured as the component of one vector along another vector multiplied by the magnitude of another vector, that is A cos theta into B, right? Otherwise A into B cos theta. Simply once again see, A cos theta is the length of A bar along B bar. A cos theta into total length of B bar, that's all. See, B cos theta is the length of B bar along A bar. That is B cos theta into total length of A bar. That is A into B cos. So A into B cos theta, otherwise B into A cos theta. That also can be written as AB cos theta. So all the steps are same. So A bar dot B bar can be written as mod A bar mod B bar cos theta. That is equal to AB cos theta. That is A cos theta into B. Also can be written as A into B cos theta. A into B cos theta. Right? Now, same can be written as, see, I am putting in box. This is number 1. Now, cos theta can be written as cos theta equal to A bar dot B bar by mod A bar mod B bar. A bar dot B bar by mod A bar mod B bar. That is A bar dot B bar by mod A bar means A, mod B bar means B. Okay. So cos theta. What for this cos theta? If you are given two vectors A bar and B bar and you are asked to determine the angle between those two vectors, then you can have this relation, that is cos theta equal to A bar dot B bar by mod A bar mod B bar. That is A bar dot B bar by A P. Okay. Now, see, for a given pair of vectors, if you change theta between them, that is angle between them, you can have different results for dot product. Suppose if theta equal to 0 degrees. If theta is 0 means A bar and B bar are parallel to each other. That is A bar parallel to B bar. Now one implies first expression implies one implies a bar dot b bar equal to a bar dot b bar equal to mod a bar mod b bar cos theta, that is ab cos theta. Mod a bar mod b bar, mod a bar means a, mod b bar means b, into cos theta. What is theta? 0 degrees. That is a into b into cos 0 means 1. Cos 0 1, that is a. So a bar dot b bar equal to ab. A b means that is a positive value. Theta is 0 means positive value ab. Now if theta equal to 180 degrees, suppose given two vectors a bar and b bar are anti-parallel to each other, that is a bar anti-parallel to b bar, a bar anti-parallel to b bar. One implies, see once again, one implies a bar dot b bar equal to mod a bar mod b bar cos theta, that is mod a bar dot b bar equal to mod a bar means a, mod b bar means b, mod a bar means a, mod b bar means b, into cos theta, into cos theta. What is theta? Theta 180, cos 180. What is the value of cos 180? Minus 1. That is ab into minus 1, that is minus ab. Minus ab. Minus ab. This time a bar dot b bar, that is dot product of two anti-parallel vectors, is negative value. Now if theta equal to 90 degrees, theta 90 means a bar perpendicular to b bar. Given two vectors a bar and b bar are perpendicular to each other. Now one implies a bar dot b bar equal to a bar dot b bar equal to mod a bar means a, mod b bar means b, into cosine of angle between them, that is ab cos 90 degrees. What is the value of cos 90? That is 0. ab into 0, ab into 0, that is 0. Means there is no dot product for perpendicular vectors. If two vectors are perpendicular to each other, we can't define dot product for them. That is vanishes. A bar dot b bar vanishes, means 0. A bar dot b bar becomes 0. Now see, for theta equal 0, a bar dot b bar equal to plus ab. For theta equal 180, a bar dot b bar equal to minus ab. For theta equal 90 degrees, a bar dot b bar equal to 0. Means there is no dot product for vectors which are inclined perpendicular to each other, right? Suppose what are the values for cosine function for acute angles, that is theta less than 90, we can have positive values. Cos theta becomes positive for acute angle. If theta is 0 to less than 90, definitely cos theta positive. Here mod a bar means positive magnitude, mod b bar means once again magnitude positive. Cos of angle less than 90, that is acute angle, again positive. Plus into plus means a bar dot b bar becomes positive for acute angle. Okay, a bar dot b bar equal to is positive for acute angle. A bar dot b bar is negative for obtuse angle. Obtuse in the sense, if theta is greater than 90, okay, up to 180, then a bar dot b bar becomes negative value. Why? Because mod a positive, mod b positive, cosine of obtuse angle means that is negative value, right? A bar dot b bar equal 0 for theta equal to 90 degrees. Okay. On clubbing all the three, what is the range of dot product of two vectors? That is maximum value plus ab, minimum value minus ab. This is 0. Therefore, minus ab less than or equal to a bar dot b bar less than or equal to plus ab, right? If a bar and b bar are two vectors, Now the range of dot product of those two vectors can be written as minus AB less than or equal to A bar dot B bar less than or equal to AB. Right? See, theta 0, AB. Theta 180 minus AB. Theta 90, 0. Right? So minus AB less than or equal to A bar dot B bar less than or equal to plus A. This is the range of dot product of two given vectors. Right? Now let us see another characteristics of dot product. Right? Dot product obeys commutative law. Dot product obeys number one, commutative law. Commutative law. That is A bar dot B bar can be written as B bar dot A bar. Why? Because what is A bar dot B bar? A bar dot B bar equal to mod A bar mod B bar cos theta. Mod A bar mod B bar cos theta. What is B bar dot A bar? B bar dot A bar means mod B bar mod A bar cos theta. See the order. See the order. B bar dot A bar, that is mod B bar mod A bar cos theta. Mod B bar mod A bar cos theta. That is mod A bar means A, mod B bar means B cos theta. Here mod B bar means B, mod A bar means A cos theta. So AB cos theta equal to BA cos theta. Okay. Right? AB cos theta equal to BA cos theta. Therefore, commutative law will be obeyed by dot product. Okay. Now let us see distributive law. Distributive law. Dot product also obeys distributive law over addition. Distributive law. Distributive means A bar dot obeys distributive law. A bar dot B bar plus C bar equal to A bar dot B bar plus A bar dot C bar. Okay. If A bar, B bar and C bar are three vectors, then can be written as A bar dot B bar plus C bar equal to A bar dot B bar plus A bar dot C bar. Means dot product obeys distributive law over addition. Over addition. Okay. Now let us see some more characteristics of dot product. Some more characteristics of dot product. What are the means? Suppose dot product of any vector with itself means A bar dot A bar, otherwise B bar dot B bar, otherwise C bar dot C bar. A bar dot A bar dot A bar. A bar dot A bar means both vectors are one and the same. Usually we define dot product for two vectors. What are the two vectors here? Given vector itself, two vectors. Means A bar only, B bar also A bar only. So go with the definition, that is A bar dot B bar. A bar means A bar only. B bar means once again A bar. So we have one relation here. A bar dot B bar equal to mod A bar mod B bar cos theta. Here B bar in the sense once again A bar only. So replace as per the given expression, that is A bar dot A bar means mod A bar into mod B bar. What is B bar? Again A bar means mod A bar mod B bar mod B bar cos. What is the angle between A bar and A bar? A bar parallel to itself means suppose if it is A bar, again this is A bar. Now what is the angle between these two? 0 degrees. Why? Because A bar parallel to itself, that is theta is 0 degrees. What is cos 0? 1. That is A bar dot A bar equal to mod A bar means A, mod A bar means A, cos 0 means 1. So a bar dot a bar equal to a into a square. A bar dot a bar equal to a square. Now a means root over a bar dot a bar. A means root over a bar dot a bar. Right? So this is what dot product of any vector with itself. Dot product of any vector with itself equal to a square. Means square of its magnitude. A bar dot a bar equal to square of its magnitude, that is a square. B bar dot b bar equal to b square. C bar dot c bar equal to c square, like that. Right? Now let us see. Dot product of orthogonal vectors. Orthogonal unit vectors. For orthogonal unit vectors, in case of orthogonal unit vectors, see x-axis, y-axis, z-axis. Now assign the unit vectors in respect to directions. Along x, that is I cap, along y, that is j cap, along z, that is k cap. These are the unit vectors. Orthogonal. Why? Because all the three I cap, j cap, k cap are mutually perpendicular. Means I dot perpendicular to j I cap perpendicular to j cap, which is perpendicular to k cap. Now let us see what is the value for I dot I. I dot I. See, a bar dot a bar means a square. I dot I means I square, mod I square. A square means mod a square. No? A square, a bar dot a bar. Mod a square in the sense mod a bar square. That's all. Mod a bar square. Similarly here, I dot I means a dot a means a square. I dot I means I square. That is I square. That is mod I whole square. Mod I whole square. What is mod I? What is the magnitude of I cap? What is the magnitude of I cap? That is mod I cap means 1 unit vector. That is 1 square. So therefore, similarly, I dot I equal to j dot j also equal to k dot k also equal to 1. Very, very important relation. What is that? I dot I or j dot j, k dot k means 1. Why? Because all the three I cap, j cap, k cap are unit vectors. As per this definition, a bar dot a bar, dot product of any vector with itself. A bar dot a bar equal to a square. That is mod a bar square. I dot I means mod I cap square. Mod I cap square means 1. J dot j means mod j cap square. That is 1 square. Mod k cap dot k means that is mod k cap whole square. That is 1 square. So in all the three cases, I dot I equal to j dot j equal to k dot k equal to 1. Similarly, I dot j. What is the angle between I and j? 90 degrees this time. 90 degrees. 90. These are not same. I is different from j. Both are, of course, both are having same magnitude, that is 1 unit. But what is the angle between these two? 90 degrees. So go with this relation. That is a bar dot b bar equal to mod b bar cos theta. That is I cap j. I dot j means mod I cap, mod j cap into cosine of mod I cap, mod j cap into cosine of angle between them. Cosine of angle. What is the angle between I and j? 90. Cos 90 degrees. Cos 90 means what? 0. 0 into something. 0. 1 into 1 into 0. That is 0. So in the same way, j dot k. What is the angle between these two? 90. K dot I. Again 90. So now itself we came across the dot product of two mutually perpendicular vectors is 0. Vanishes. So in the same way, therefore, I dot j equal to j dot k equal to k dot I equal to 0. So this is also important relation. So once again see, I dot I, j dot j, k dot k. Dot product of I dot I, j dot j, k dot k, that is 1. I dot j or j dot k or k dot i 0. Why? Because angle between these two 90, between these two 90, between these two 90. For orthogonal vectors, whether it is unit vector, whether they are unit vectors or non-unit vectors, or for orthogonal means which are mutually perpendicular to each other, we don't have any dot product, vanishes. Okay, all right. Now let us see how to find dot product of two vectors in terms of components. Based on these two relations, we can determine dot product of given two vectors in terms of components. Right? The next characteristic, in terms of components, suppose A bar dot B bar. Say A bar equal to AX into I cap plus AY into J cap plus AZ into K dot B bar. Say B bar equal to BX into I cap plus BY into J cap plus BZ into K cap. Right? So A bar AX into I cap plus AY into J cap plus AZ into K cap. Similarly B bar BX into I cap plus BY into J cap plus BZ into K cap. So simply alphabets, not numericals, alphabets. First let us see in terms of alphabets. Later on we can solve given problem. Right? Okay. Now see, A bar dot B bar equal to A bar dot B bar. See, A first term into first term, AX BX into I dot I. See, here I dot, here also dot I dot I. I dot I means what? 1. So AX BX into 1 plus first term into here second term, that is AX into BY into I dot J. First term into second term. I dot J means now itself we came across I dot J means 0. So I dot J 0 means no need to. AX BY into 0 means 0. I'm not writing. AX BY into I dot J means 0. So no need to write second term. Yes. Once again, first term into third term, that is AX BZ into I dot K. I dot K means what? I dot K or K dot I, whatever it is, 0. Why? Because what is angle between I and K? 9 degrees. Means dot product vanishes. So first term into third term also 0. Okay. Plus now second term into first term, that is AY BX into J dot I. Once again J dot I dot J or J dot I, once again 0. Why? Because mutually perpendicular. So first term, second term into first term 0 plus second term into second term, that is AY into BY into J dot J. J dot J means 1. So 1. We have AY BY into 1 plus second term into third term, that is AY BZ into J dot K. Now what is J dot K? 0. So 0. Okay. Now coming to third term into first term, that is AZ BX into K dot I. K dot I means 0, means plus 0. Now third term into second term, that is AZ BY into K dot J. J dot K or K dot J? 0. Commutative law, right? 0. Okay. Now third term into third term, that is plus AZ BZ into k dot k. K dot k means, what is k dot k? 1. We left with az, bz into 1. Now, what is the ultimate result? A bar dot b bar can be written as ax bx plus ay by plus az bz. Az bz. So this is ultimate result. So in terms of components, a bar dot b bar can be written as sum of product of similar components. So ax bx plus ay by plus az bz means x component to x component plus y component into y component plus z component into z component. Other terms are 0. Why? Because angle between other unit vectors means j between j and I, j and k 0. Between I and j, I and k 0. For numerical, if a bar equal to minus 2i plus 3j plus k and b bar equal to 3i plus 5j, find a bar dot b bar. See, a bar dot b bar. A bar dot b bar equal to ax bx plus ay by plus az bz. So ax bx plus ay by plus az bz. What is ax here? Ax minus 2, ay 3, az 1. 1 into k, that is 1. So ax minus 2, ay plus 3, az equal to 1. Similarly, bx equal to 3, by equal to 5, bz equal to 0. Why? Because there is no z component for b. So ax minus 2 into bx 3, okay, plus ay 3 into by 5 plus az 1 into bz means 0. There is no z component for b. That is minus 6 plus 3 into 5, 15 plus 1 into 0, 0. So 15 minus 6, that is 9. A bar dot b bar equal to 9. Right? Similarly, if a bar equal to I plus 3j plus 4k and if a bar equal to so and so and b bar equal to 2a plus 2j minus bz into k. Bz into k are mutually perpendicular to each other. Perpendicular to each other. Find z component of b, that is bz. Find bz. See, you are given two vectors. A bar is so and so, b bar is so and so. What is the data here? A bar and b bar are mutually perpendicular to each other. Find bz. How to find bz? See, one clue is there here. What is that clue? Clue point, that is a bar and b bar are mutually perpendicular. For perpendicular vectors, their dot product must be vanished. That is a bar perpendicular to b bar in the sense implies a bar dot b bar equal to 0. Right? Now take their dot product to be 0. That is a bar dot b bar means ax bx plus ay by plus az bz equal to 0. Right? Ax bx, ax is 1, ay equal 3, az equal 4. Similarly, bx equal to by equal to bz equal to minus b. Okay, that is ax 1 into bx 2 plus ay 3 into by 2, 3 into 2 plus 3 into 2 plus AZ means 4. 4 into BZ means here minus BZ. Minus BZ. Minus BZ. That is equal to 0. Right? That is 2 plus 6 minus 4 BZ equal to 0. So 2 plus 6, 8 equal to 4 BZ. 4 BZ. So BZ equal to 8 by 4. That is 2. So what is the Z component for B bar? That is 2. Okay. Now coming to important topic, that is one more important point. Component vector of A bar in the direction of other vector. Let us see. Let us see. We know that AB cos theta equal to A bar dot B bar. Am I right? AB cos theta equal to A bar dot B bar. Right? Now, if we make it subject A cos theta equal to A bar dot B bar by B. Right? A bar dot B bar by B. See, this is A bar. Now, this is B bar. What is the angle between these two? Theta. Now, take normal from tip of A bar to onto B bar. This is what A cos theta. Similarly, take one more normal from tip of B bar onto A bar. Now, this is what B cos theta. Okay, this measurement A cos theta means the length of A bar along B bar. Similarly, this is what the length of B bar along A bar. So A bar finds component of B bar in its direction. Similarly, B bar finds component of A bar in its direction. A cos theta. Alright? Now see, A cos theta in the sense component or length of A bar, otherwise projection of A bar in the direction of B bar. Means scalar, it is not in vector notation. Scalar. Why? Because A means magnitude. Cos theta also on scalar. Scalar into scalar. Scalar. So scalar component of A bar along B bar. Right? What is the unit vector along B bar? That is B cap. What is the unit vector along A bar? That is A cap. That is A cap. So A cap is the unit vector along A bar. B cap is the unit vector along B bar. Now, if A cos theta is multiplied by, this is what A cos theta from here to there, means magnitude of A bar along B bar. If it is multiplied by B cap, then it becomes vector. Why? Because magnitude multiplied by unit vector in the direction. That is A cos theta into B cap equal to A bar dot B bar by B into B cap. So multiply, it is to be multiplied with B cap on both sides. Say this is magnitude multiplied by unit vector, means component vector of A bar along B bar. So component vector of A bar along B bar. So A cos theta multiplied by B cap. A cos theta alone component, not component vector of A bar along B bar. If it is multiplied by B cap, then it becomes, this total term becomes component vector of A bar along B bar. So A cos theta multiplied by B cap. Similarly, B cos theta multiplied by A cap, nothing but a component vector of B bar along A bar. B cos theta alone, component, not component vector, component of B bar along A bar. B cos theta into A cap, in the sense component vector of B bar along A bar. So we know that similarly A here A cos theta equal A bar dot B bar by B. Similarly, B cos theta equal to B cos theta. See, from this relation, B cos theta equal A bar dot B bar by A. A bar dot B bar by A. B cos theta equal A bar dot B bar by A. This is what component of B bar along A bar. It's not vector, simply component, scalar form. Okay. If it is multiplied by A cap on both sides, that is B cos theta into b cos theta multiplied by a cap equal to a bar dot b bar by a multiplied by a cap. See, magnitude multiplied by unit vector. Magnitude multiplied by unit vector along a bar means component vector. This total term becomes component vector of b bar along a bar. Okay. See, component vector of b bar along a bar. Why it is along a bar? Why? Because here unit vector is along a bar. That is a cap. Here b cap. That is b bar along b bar. Okay. Here along b bar. Here along a bar. Right. Now let us see one numerical. Okay. One numerical based on this explanation. Suppose if a bar equal to 2i plus 3j and b bar equal to I minus j. Okay, if a bar equal to a plus 3j and b bar equal to I minus j, right, that is I minus j, find component vector of a bar perpendicular to b bar. Component vector of a bar perpendicular to b bar in the same plane. See, a bar is so and so, b bar is so and so, and find component vector, not component. Component vector of a bar perpendicular to b bar. Now let us see solution. So this is what a bar. Alright, this is what b bar. Let theta be the angle between these two vectors. Alright. Now we need to find a component vector. Before that, we need to express component of a bar perpendicular to b bar. See, component vector of a bar perpendicular to b bar. Now let us see. If I take one normal from the tip of a bar onto b bar, this becomes opposite side with respect to theta. This becomes adjacent side with respect to theta. So adjacent side means a cos theta, which is in the direction of b bar. Opposite side means a sin theta, which is perpendicular to b bar. So a sin theta is perpendicular to b bar. Okay. In fact, it is component. If it is multiplied by some unit vector, then that could be the required vector, which is component vector of a bar, which is perpendicular to b bar. See, a cos theta is in the direction of b bar, that is parallel to b bar. A sin theta is perpendicular to b bar. We need to find this vector. A sin theta vector, not scalar, vector. We need to find this vector, right? Now say c bar equal to xi plus yj be the required vector. Such that c bar is perpendicular to b bar. Now this is the required vector. As an example, with components x and y, we need to find x component, y component, and is to be replaced in the same expression, right? Now let us see what is the magnitude of c bar, root over x square plus y square. That should be equal to a sin theta. Why? Because this is what component of a bar, which is perpendicular to b bar. This is a component in the sense magnitude of required vector, which is perpendicular to b bar. So mod c bar must be equal to a sin theta. So mod c bar equal root over x square plus y square, that is equal to a sin theta. Right? That is root over x square plus y square equal to a sin theta. What is a? Modulus of a bar. That is root over 2 square plus 3 square. Root over 2 square plus 3 square into sin theta means root over 1 minus cos square theta. Sin theta in the sense root over 1 minus cos square theta. Okay. In dot product we have only cos component. There is no sin component. That is the reason why I am replacing sin theta by writing root over 1 minus cos square theta. Right. Root over x square plus y square equal to root 9 plus 4, that is 13, into root over 1 minus cos theta. What is cos theta? We know that a bar dot b bar equal to ab cos theta. Now make it subject cos theta. Cos theta equal to a bar dot b bar by ab. That is cos theta means a bar dot b bar by a b. This is what cos theta, but here it is square is there, so square like that, right? Square cos square. Okay. Now root over, I am squaring on both sides. Here root will be gone, here also gone, here also gone. That is x square plus y square. I am squaring both sides. X square plus y square equal to 13 into 1 minus a bar dot b bar by ab whole square. Now let us see x square plus y square equal to 13 into 1 minus a bar dot b bar. A bar dot b bar means 2 into 1 plus 3 into minus 1. So 2 into 1 plus 3 into minus 1 divided by AB. A means mod A bar, root over 2 square plus 3 square. Root over 2 square plus 3 square into B means mod B bar, root over 1 square plus minus 1 square. Root over 1 square plus minus 1 square. Okay, minus 1 square. Here whole square is there. Whole square is there. That is x square plus y square equal to 13 of 1 minus, see, 2 minus 3 means minus 1. Minus 1 square means 1. Divided by root 9 plus 4, that is 13. Here root 1 plus 1, that is 2. Whole square is there. Whole square is there. That is x square plus y square equal to 13 into, see, root 13 into root 2 means root cancel and square, that is 13 into 2, that is 26. 26 into 1, 26 minus 1, 25 by 26. 2 times, that is x square plus y square equal to 25 by 2. Number, this one number 1, this one number 2. Okay. Now see, C bar is perpendicular to B bar. That is, we know that C bar is perpendicular to B bar, implies C bar dot B bar must be equal to 0. C bar dot B bar must be equal to 0. What is C bar? Xi plus Yj. Xi plus Yj. Dot B bar. What is B bar? I minus j. I minus j equal to 0. That is x into 1. X into 1 plus y into minus 1 equal to 0. So x into 1 means x. X into 1, x plus or minus y implies x minus y equal to 0, x equal to 1. X equal to 1. X minus y equal to 0 implies x equal to 1. Means x and y are same components of equal magnitude. So here 2 implies we have x square plus y square equals to 1, so 25 by 2. Now both x and y one and the same. Replace y with x, otherwise x with y. So 2 implies, what is that expression 2? 2 implies x square plus y square. Y again becomes equal to x. So x square plus x square. Since y equal to x. X square plus x square equal to 25 by 2. 25 by 2. That is 2x square equal 25 by 2. X square equal 25 by 2 to the 4. Implies x equal to root over 25 by 4. That is 5 by 2. Here x and y both one and the same. Therefore x equal to y equal to 5 by 2. So we have x and y values, which are nothing but components of C bar of required vector. That is, one implies required vector C bar equal xi plus yj. That is, C bar equal xi plus yj. X means 5 by 2, y means 5 by 2. So 5 by 2 I cap plus 5 by 2 j. This is the required vector, which is perpendicular to B bar. Why? Because we started from this expression, C bar perpendicular to B bar, means their dot product is equated to 0, from which ultimately we have x and y so and so. Therefore C bar equals so and so, which is perpendicular to B bar. Okay friends, signing off for today. Once again requesting all the audience, please subscribe C level physics. Please don't forget to like my videos, share my videos and comment on videos. In next class, we deal with the cross product or vector product. Thank you.